Okay, here we go. Let me get spun up here. Start my Pollen server. Welcome everyone. Welcome all of you who are hapless YouTube viewers of the future who are hitting play and enduring my unavoidable 2 minutes of dead air before I get started. Dex. Petri. Just want to get our Pollen project up here the way that we like it. It's a little bit slow, and I know that my CPU is old and works a little harder while I'm streaming. There we go. There's a Pollen cookbook. Example page. And then I'm going to pull up the GitHub page for the project. By way of a to-do list for this evening, I started some issues on the GitHub repo. So backing up a little bit, in case you're not familiar, this is a streaming session about Pollen, which is a Racket language for publishing web pages and books, and I can do anything really. I could publish an audiobook, we could publish a blog, we could publish an ebook. So by way of illustrating how to do these things, we're creating a book called the Pollen Cookbook. And it's not much to look at yet. All we've done so far is illustrate how to get these little fancy footnotes that are similar to the beautiful Racket web book, if you've seen that. And some basic tags for code blocks and paragraphs and things. And as I was saying, by way of creating an agenda for this session, I've avoided working on this project between streaming sessions. Maybe this is misguided, but right now my thought is that everything you see in the project will have happened during a session, so I won't be doing something and then telling you about it later. Might change that in the future, but this is what I've got here. Needs organization. So rather than just being a single page of stuff, we're actually going to make it a book. We're going to have chapters. We're going to have sections, a little preamble, what have you. Needs a way to be organized. And right now, all we have in the project is a single Pollen document, which is the result of what you see on the browser up there. Code. So yeah, here we have Pollen. Here's the Pollen Racket file, and then our CSS preprocessor file, and our example page that you see here. I'll open that. I should really close that window because that one's kind of a gnarly for one of my other projects. Okay. You can see here's the markup here that's producing this page here. And I've got a defined citation. So instead of just having this one page, I kind of want to have a table of contents, and then each individual page will describe a new technique or a recipe if you were going with the cookbook metaphor. So that's one of the issues. I need a way to illustrate how to write Pollen code in the cookbook without writing everything twice, because there's the source code that produces the book, which also contains source code in theory. So we're going to find a way to solve that problem, as I mentioned in the email, and then should avoid side effects from namespace reuse. This is a little bit of an involved topic. I'll try and make it as simple as I can, but the way that we currently do our citations define citation, and then insert the citation. The define citation tag function that we created in the last session works by taking a hash table and adding entries to it. And that works fine for a single page site, and it previous to a week or two ago actually would have worked fine, but a Pollen project has many pages, and they may be, depending on how you build your site, you may build more than one page at a time. And previously Pollen would go out of its way to create a fresh blank slate for each page as it was rendered. This was nowhere explicitly guaranteed in the documentation, but it was the behavior. And now Matthew Butterick has changed Pollen so that it will no longer make that guarantee. If you render several pages at once, all the variables in your Pollen.racket will be shared by all those pages, unless you take steps to separate out that data. So what that means for this project is that the hash table that we are using in our define citation, tag function is potentially going to be reused among more than one page at a time, which means if we first of all, it means that if we define a citation with a particular key, like this zmuse here, we may end up clobbering a citation from another page. And it also means that every page that uses this insert bibliography here to insert the bibliography at the end, as we see down here, the way it's implemented now, it's actually going to insert a bibliography for every page that's so far been rendered in the current process. There's simple ways to get around that. Let me first of all illustrate the problem. So why don't I create a second page? Hey, let's do a new. I apologize for my computer being so slow today, but maybe it's time to upgrade. It is a bit of an old laptop. Okay, we're not laying Racket, we're laying Pollen. I may end up switching to Vim if it persists, but let's see here. So I'm going to define another citation. I'm only going to define one. And before I go any further, I'm going to save this file so it knows what Pollen project is a part of. I'm going to do page2.html.pm. Oh, I just put page. I must have missed a key. So define citation. We're going to call it Joel. Just call it Joel's private diary. Here's some text from my private diary, and then we'll put the cite tag. And at the end, we'll insert another bibliography. I'm kind of flipping freeform between the Pollen markup syntax and the more rackety kind with the parentheses that you see down here. I think I got that syntax right. Let's go back to here. I don't know if I can refresh this or if I have to restart. Nope, I can. Here's what that looks like. Okay, now in the browser, when you're using the web server, Pollen will rebuild a fresh namespace for every single page. So you're never going to be able to reproduce this problem or this behavior that I'm about to show you, that I haven't shown you yet, in the Pollen server. But I'm just making sure that my page is set up here. That looks good. So let's do something here. Let's break the breakout of the project server. And we'll go to we'll do a Rako Pollen reset to clear the cache. And we'll also remove all of our HTML output files. Rako, no, it's just remove star.html. Hopefully this is big enough to see down there. There we go. And we will then Rako Pollen setup dot for the current directory. I think this is going to work. What that's going to do, oh, what have I got going on here? Contract violation. This isn't supposed to happen. Preheating the cache. Do explode file. Not sure I understand what's going on there. I'm just going to do Rako Pollen render to HTML star.html. No, I'll do it this way. I'm going to do render example.html and page.html. Better not blow up on me live like this. That's not cool. So what I'm doing here is I'm making the decision to trigger the behavior that I'm about to show you to build both of these pages in one go. So the same process is building both of those pages, which means that Pollen is reusing the variables between those pages. It's not resetting them in between each page. So I'm going to open up the folder in my Finder here and just manually, I don't know if I can just go like this. Now here's our example page. And here is our page. You'll notice my page has in its bibliography not just Joel's private diary, but all these other ones as well that I didn't use in here. Now, probably in a real project you will want to reuse a bibliography across multiple pages, so maybe that's what you want, but that's not the way we expected it or designed it for our example here. So we're going to make this so that each page has its own bibliography. That's going to be our desired behavior, just for the purposes of an example here. You know, the other one, if I go back and refresh it, and this one I only did get one. I only did get the bibliography for the citations that I defined in that page. That worked. But that happens to be because the word example comes lexicographically before the word page. I should say alphabetically before the word page. So Pollen rendered, maybe it's because of the order I had it on the command line, I'm not sure. Pollen rendered this one. And then it reused the same variables and rendered this one. And when I did this one, we still had these citations sitting around back here. So that's what this issue on the Pollen Cookbook repo, the Cookbook Pollen repo, is about. How do we keep that from happening? How do we separate data so we know we're getting only data for the page we want, if that's what we want? So why don't I tackle that one quick first, and then we'll go on to the organizational stuff. Okay, so that's going to mean opening our Maybe did I already have it open? I don't think I did. I'm on the wrong app. Opening the pollen.rkt racket file, taking a look under the hood. We got fewer people watching tonight. I'm sure the weather's looking great. Nobody wants to talk about this stuff. But we had a top viewership of 7 people last time, and now that video is up to 75 views. So all of you, the 2 of you who are lucky to be watching now, are being joined by potentially between 20 and 100 future people. So maybe you want to leave them an emoji or something. No pressure. So here's our tag functions in the pollen.rkt file. And our citations table is a hash table right here. It's being defined globally, kind of at the module level. And we're just kind of mutating it in place, which is a little bit unrackety. In a functional language like Racket, you don't keep variables and then keep changing them. What you do is you pass variables into functions, and then you get the results back out of the function. And then you just kind of chain up all these functions. So you really don't need to. It's considered harmful in some cases to have this state hanging around. That being said, if we want to, so the truly rackety way of doing this actually would be to actually implement our root function. If I go back here and run one of our Pollen documents, you see that I get an X expression that starts with root, or root, depending on what state you're from. And this, actually, if we implement a root function, it will then have the last bite at the apple, go in and, do whatever it wants with all of these things. And so what we could do is have these site tags kind of show up in here as site tags, and then the root function at the very end would go in and flip all those over into our span expressions that we see here with all that kind of on-click events and the CSS markup that we need to get this tricky little effect here. And then where would it be getting those citations from? Well, it could still be getting them from a hash table, or it could be getting them from other tags that we leave intact in the document tree here. Do we want to try that now? I'll show you the simple way first, and then we'll see what you think. But that's one way to go about it. The other way is that we actually do have a hash table that is guaranteed still and always to be unique per page, and that is the current metas hash table. Let's pull that up in the docs. pollenpub.com. Let's see here. I'm going to make it a little wider so I get the right thing here. Module reference core current metas. This function will return the hash table, the metas of the Pollen source. So whenever in a Pollen document you use the built-in define meta, we could do it this way. Title. My second page. Now that's not going to change the output of the page directly. It's not going to appear in here anywhere. It's just going to print an entry into that hash table. And this is often how you will opt to put in dates for published dates or titles or author names. It's like a YAML header in a markdown document, except you can do more with it, and the syntax is, in my opinion, easier to read, or easier to get right. So that's what metas is. That's guaranteed to be unique for each page. So what we could do is, rather than using this global citations table, we would grab a citation, a hash table out of current metas. So let's define ctable to be hash ref current metas. We have to call a function with 0 arguments called current metas. It's not a variable per se. It's actually a function that will return you an up-to-date value. And we'll just call it ctable. And what should we get if it's not in there? We should get, I think, a hash. That's what we had before, right? Yeah, make hash. Maybe I think you just pass it the name of a function to call. Let me just make sure on that. Hash ref failure result is either a function of no arguments or anything else. So if it is a function, it'll call it. So I'm just going to give it the name of this make hash function to give me an empty function in the event that it doesn't already exist in there. Now, what I want to do is update I want to update this hash table with the citation, the new citation, and then I want to update current metas with this new citations table. So we'll do it the stupid ugly way. Just define a bunch of stuff in order. Define, you could say updated. And then I'm going to, it's too bad I'm not in Vim right now. And then that's my updated one. And then I'm going to, so this is why current metas is actually a kind of thing called a parameter. You see that here in the documentation it says parameter. A parameter is a special kind of a function that you can call it. If you call it with 0 arguments, you'll get the current value. Or if you call it with 1 argument, it will replace the value with the new value. This sounds like a global variable, and in effect it kind of is, but it has the advantage that you can temporarily set a parameter within a scope of code. And when that scope ends, the parameter will automatically reset to whatever it was before. Move the pawn, I reckon. Oh, you're right. Sorry about that. How's that looking? Sorry about that, Zach. I drifted. Okay. The incredible value of having live chat during one of these sessions is that it can occlude your coding window, and then people can then use it to tell you to stop doing that. So, okay, so that's so much for parameters. And the other virtue that parameters have is that they're thread safe. So if you're doing something multi-threaded, each thread gets a fresh copy of the parameter and doesn't have to worry about clobbering on the other threads. But anyways, so what we're going to do is current metas hash set current metas ctable updated. So now our defined citation does not actually even use this table. It's using a different table that we're storing in the current metas under the key ctable. Let me see here. So what I'm actually going to do in order to make it easy to refer to that citations table is I'm going to make that a no argument function. Instead of a variable, I'm going to make it a function that notice I'm duplicating some code I just wrote below it. So actually I have the opportunity to, I'll never get those keystrokes back, but I can actually get rid of this line now. And replace it with the call to this function. Okay. So I can get it out here and then put it back in here. So then I've got down here, this becomes a function call instead of a identifier or a variable. It's going to call that function to get that hash table. And now insert bibliography. I think the only thing I need to do is change this reference here and this reference here to use the function version instead of the variable version. Okay, you'll notice I'm getting an error at the bottom. Current meta is unbound. I've got a grab. You'll notice current metas is defined from, if you go to any function or thing in the Racket documentation, you can just hover over it to see what package you need to require it out of. So, or to require in order to get it. So I get Pollen core. That's what provides that binding. Save that. Now, I think if I kind of remove my HTML again, and then if I let's do a reset just to be sure. And then I'll do the same thing I did above. We should get each page should have its own bibliography now, separate from the others. Unless I got a bug, which is likely. I got a bug. I've passed hash set with the exclamation point. Oh, now it's giving me a void. It says that I've passed it a void value instead of a hash table, and that is well, the only place I'm using hash set with an exclamation point anymore is here. Let's just let's take a poke around in here. Let's save all files. See if I should have done this first. Tested my functions to make sure that it. See if I call citations table now, I should get an empty hash. Nope, I'm getting an error. But there is no current metas, so let's do this. I'm just going to manually set the current metas, and the reason there's no current metas now is because we're not in the context of rendering a document, so there's no metas to be had. I'm just going to make hash. Okay, now, so now there is a current metas as if we were in a document, and I have called this function, and it's given me an empty hash, I believe. So it's looked for a ctable value in current metas, found none, and used this make hash as the failure result. Let me try running this contract violation hash ref. Expected a hash. Instead, it's getting a void. Why don't I do this? I'm getting my empty hash here. Why don't I try defining a citation? Joel. I think I'm giving it, I think I'm creating the wrong. I run up against this every once in a while. There's two types of hash tables. There's mutable ones that can be changed, and there's immutable ones. And I tend to get them confused because of how mediocre I am. So hash is the one that gives us, of course, the immutable. Do I want an immutable? I will do an. I'll switch to doing immutable. See, this hash set with the bang here tells you that I'm mutating it. So maybe better not to mix and match. You can in theory, but I'm just going to try and simplify it here. I know that I'm getting. If I do it now, I'm going to set up that fake current metas. I'm going to set up my citations table, and then I'm going to set up the. I did that already. I'm given a hash. Maybe that is a mutable hash. I'm confused as to why, because when I look at make hash, I get a mutable hash, which is what I want. Oh, I'm sorry. I didn't. This error message is for hash set without the bang, which means it's failing here, not up here. And it means that current metas is it's expecting an immutable hash, which means that current metas is mutable. Which is surprising to me, but I think it means that if I just put a bang on the end of this, it'll work. Because it'll use the mutable version. I hope I'm making any sense at all right now. I gotta set up my empty current metas. I'm gonna look at my table, and I'm gonna define a citation. That works. Hash ref is void. What does our current metas look like? It's a void. That's because the result of hash set changes the variable and does not return a value. So yeah, what we're learning about here is the importance of being clear about whether you're doing things functionally or imperatively. If you're mutating variables, let's just get away from all that, because then we can't chain functions together. Not those particular functions, not in the way we want. So I'm gonna go for immutable hashes all around. We're gonna replace that with a hash. I'm gonna do this. We're gonna do this. I think that'll work, actually. I think that's, as long as we're being homogeneous about this. Okay, I got my fake current metas. got a citation, hash set. Oh. Can I put an immutable hash in metas? I might cheat a little bit because I worked on this actually when I was creating some test cases for the GitHub issue. This would have been maybe a week and a half ago by now. But I did not use... In this example, I called it sim table, which is an immutable hash. I hash refed the old value, I hash set with the new value, and then I hash set current metas with the new table. Very similar to what I've got going on up here. And I tested this. This worked too. Oh boy. Well, this is what we get. So, for some reason, it's not considering this hash immutable. Current metas, hash set, current metas, C table, updated. This is giving us a new citations table. And then we're setting it and updating it here. So it's giving us the error in hash set. Let's have a peek at current metas. It's this empty hash. You know, if I go to this looks a little funny to me. The form of this this hash table. I wonder if that's accurate. See, I've used an immutable one here. Let me, I think I know what's going on here. It's because of the way I'm setting up my test. I'm using make hash. Let's do that. So instead I'm going to use a immutable one. Okay, there we go. Now it appears to be working. It is difficult to debug Pollen, but there are these categories of things you tend to run into. And, you know, you wouldn't believe it, but I write basic code. And I don't mean that as the adjective. I mean the language basic at work for a living. So I got to go from the third grade computer language of the 1980s mindset back into Racket when I get home from work. So I at least that's what I attribute my brain damage to. But in Racket, it is confusing, and they're talking about in the next iteration of whatever Racket language is trying to eliminate some of the confusing name things around things like hash tables, or equality is another tough one. So what I was doing there and trying to test my thing was I was populating the current metas with my own hash table, but I was using a mutable hash table, which is designed to be modified in place. I think, actually, now that I recall, when you have an actual Pollen document, I don't think you end up with the type of that hash table is an immutable one. So this should work now. Where were we at here? Let's try this. Okay. It looks to me like this is correct. Now, I'm not going to be able to reproduce the shared state between pages behavior right in here, but at least I'm getting the same output I was before. So now I think I can go back down here and remove my HTML. And, oh, I didn't have any yet. So then I'm going to render. Let me move this window up a bit. Render both those pages. And now the idea is that I will get pages, even though they're being rendered in the same thread. If I refresh this, now I can't find the file. What's going on here? Rico, Pollen, reset. What does it say? No paths to render. It might be that I'm in the I'm in the wrong directory. Sorry about that, folks. Let's do this. Okay, now that I'm in the right directory, it should work. I don't know if you can see my CPU monitor in there, but it's just hovering at 80%. I think it's because it's doing all this transcoding for the stream. It's normally a lot faster than this. So now finally, so even though I rendered those both at the same time, I only got, this bibliography only has the citations that were defined on this page. And if I refresh this one, I only have the ones for this page. So this one actually was that way before, but on this page I was getting all three. And we decided for the purposes of illustration that we didn't want that. So yeah, we got that working. So let's kind of rehash where we ended up with that. Rather than putting everything in a global variable, I decided to kind of add a meta into the current metas hash table that would serve the same purpose. And the reason for that is that I know that current metas is, Pollen by design is not going to share meta values between pages. So that's where we're storing those citations now. I think, it's 7:45 already. I think for the purposes of illustration, I will try and show you, because here's a weakness that our citations thing has right now. The way we do this, I have to put my definitions at the top. Otherwise, if it gets to here, there's not going to be a value in the hash table for that citation unless the program has already encountered it. We want to be able to maybe put our citations at the bottom. We should be able to do this. And we should be able to get it to work, but you'll notice you know, my bibliography still has the entry, but you'll notice that by the time it gets to that tag, it hasn't seen that citation yet. It's saying no def for Joel. That's the error message that we designed into this tag function if there was no matching key for that citation. So how can we solve the shared state between pages problem and solve this problem right here of having to care about putting where we put our citation definitions? The probably more idiomatic way to do this, rather than updating a hash table, although that will work perfectly well, is to kind of keep these, both the definitions and the citations, in the document tree, as it were, this tagged X expression, and then kind of recurse down the tree afterwards and process them all at the very end using the root tag. I'll show you what I mean. I'm going to, I think what I'm going to do, maybe we kind of want to preserve what we've done here so that you can refer to it. So I am going to create a new file, and I'm going to save these functions in that file. You can do lang racket. Lang racket base will save you some memory when you're doing things, because it imports a far smaller collection of packages by default. So I'm just going to copy these into there, and they will be in the repo if you want to use them that way. I'm going to go down, 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 down. Control. I'm actually going to go Control X. I'm going to do this very destructively. Okay, so we're going to put okay, I'm just going to save that as alt citations. I'll keep it open. I'll probably end up pasting some code out of it or something. And so now I've thoroughly broken. So we need to redefine those tags. What do those tags do? What is citations table? What is define citation key and cite key? What do those functions do now? Well, let's do this actually. I'm actually going to do, cite is not going to do much. It's going to how do I want to do this? It's just going to create it's just going to create a new tagged X expression with the cite symbol, and it'll have a ref attribute, and I'll put the key in there. That's all that's going to be in there at the time that function is called. And then I'm going to have a define citation key elements. Remember, that's that rest argument with the dot. The dot and the binding, or the ID identifier, gathers up everything else into a list, any number of arguments that follows. So I'm going to have that do something similar. It's just going to be kind of a dumb cite def tag, we'll call it, and we'll give that a ref attribute. Same deal. And then the elements of that will be spliced in there. And I think I'll put a placeholder in for that is all that is going to do is, you know what, I can save myself. Well, I'll just do this. This is going to look a little redundant, but that's because it will be. I'm just going to put a bib tag there. That's it. It's just kind of a little marker. All these are really just markers. So I'm going to save that. I'm going to go back here. And I'm going to... Here I'm citing a citation that I haven't defined yet. I think I will define another one up here, just to show that it won't matter where we put them now. How I raised myself from failure to success in selling. Oops, that's too many. Okay. I'm not referencing that anywhere, but let's just run this and see what it looks like. I have an error, pollen markup error, contract violation. I'm producing an invalid X expression somewhere in here. It may be that my... Oh, see, it's expecting, so site def ref rank doesn't like that. In. So it expected, but it's not telling me what it expected. I think part of this is that I have omitted some debug info from my racket language in order to make it run more quickly. Let me see if this doesn't kill my computer. I'll add debugging info back in there. I've removed debugging and profiling here, so. Pollen markup error. I know that I omitted that debugging information for my REPL, so maybe putting it back in will give me... Yeah, pollen markup error. Contract. Well, let's take a look at the X expression. Site def ref rank. How I raised myself from failure to success in selling. Is it the fact that I believe what I'm running into here, just looking at, so familiarizing yourself with what is and what isn't a valid X expression is going to save you a lot of time, and I've mentioned that before, but I realize what's happening here. A tagged X expression has to have a symbol at the beginning. So that's our symbol there. And then it can have a list of key value pairs, but the values in those pairs cannot be symbols. They have to be strings. Yeah, they have to be strings or numbers, datums. Pretty sure they cannot be symbols. And I've taken a symbol here and dropped it into what is supposed to be a valid tagged X expression. The simple way to convert that value to a string, no matter what it is, I'm in the wrong file here, aren't I? Let's go back to pollen.rkt. See, I cannot just insert this as is. I actually have to... The simple way to do this is to use a format string. So whether it's a number, whether it's a symbol, whether it's already a string, it will now be converted into a string. Okay. I think I have to do the same thing here. That is what is going on there. I can guarantee it. So Pollen did not give me a very helpful error message there, and I don't know when or how that will ever change, but I do know that when you get contract violations at this stage of just testing out your Pollen document, you're going to probably want to start looking hard at the X expressions that you're generating. Are they really valid? You know, if you had 3 elements in this attribute list, which again, another way of testing that is, would this translate into something sensible in HTML? HTML, you never have 3 elements in an attribute list. You might have single attributes, or you might have key value pairs, or name, attribute value, but you never have 3. So if it wouldn't make sense in HTML, it's almost certainly not. But also the string requirement. Things are either symbols or strings, and they can only go in certain places. So the first part of this expression has to be a symbol. The first value in the attribute lists has to be a symbol. And elements that follow attribute lists have to be themselves X expressions or strings. I think they can also be numbers as well, and those get translated into numeric entity codes, ampersand codes in HTML. So we are getting what I hoped for here. There's the site definition. It's just a marker. Here's my reference, but it's not really doing anything special at this point. And then there's another site definition. So how to actually translate this into what we had before? What we want then is our root function, which is the magic function that gets called at the end. And this is where we're going to get rid of, by the way, if you've noticed in the HTML output, if you've been tinkering around with this, we end up with a root looking HTML tag here. That's because of this. We're not doing anything with that, so it just gets left in the output. But we can actually fix that little issue as well and create a bona fide, div or section tag. So let's go ahead and do that. Where am I at here? Here's Pollen. And I am going to close that. Define root, function of root, elements. So our elements are all the X expressions that are directly within the module level here. And what we want to do is 3 things. We want to grab all the definitions out of there. And then we want to replace all citations with references to that definition. And then we want to produce a final X expression for the doc. So it's not in Pollen per se, but we're going to want to import the txexpr package here. This is all kinds of utility functions for dealing with tagged X expressions. And you can hear the kids playing around over there. There's a couple of pretty magical, useful functions in here. One of them is splitf tagged X expressions. You give it a function, And it will descend into a tagged X expression and find all the matching, use the function you give it to find the matches, and pull those out of the first tagged X expression into a separate list. So that could be useful for grabbing our definitions. So I'm going to say what we need is, first of all, we need a little helper function. Is sitedef tx. I need a function that can see if a tagged X expression is one of our citation definitions. So down here we're producing this little sitedef X expression. So we want to look for those. We want a function that can help us look for those. So first of all, is it a tagged X expression? And second, is its tag. Remember, the value that might get passed to this could be a string. So first of all, we want to rule out the string. Second, we want to see if the tag is sitedef. And I think those are the two things. So then we want to define defs, sitedefs. We're going to use that splitf txexpr. I want to give it a full tag. You'll notice the function wants a full tagged X expression. So I can't just give it a bunch of elements. I have to give it a full X expression that starts with its own tag. We don't care what that tag is, so I'm just going to create a temporary one here. So there it is. It's going to splice everything in there, and then I'm going to say the procedure that you want to use is sitedef. We're not going to replace them with anything, which by default you see here is it's going to remove. Ordinarily, the result of the split operation is to remove the elements that match pred. We're going to get two values back. So actually, I probably want to do define values. Can I use a blank, an underscore there? I think I can, because I don't care about the first one. I only care about the list of matching results. Then I want to, so that's actually, that takes care of my, after I've got this sitedefs will contain a list of all the matching citation definitions, and I probably want an easy way to look those up. So what I'm going to do then, that's gonna look like, that's going to look something like this. I don't know if it's going to basically be a list of, how do I put this? These, and I'm going to want to have a quick way to look those up. And the easiest way would be to stash them in a fresh hash table somehow, or at least an association pair. So I'm going to define a new table. That will act like that will be a hash table. I'm going to loop through. This is kind of a list comprehension syntax. C in list sitedefs, the one that we just got up there. If you use for hash and iterate through a list, and then for each item in the list you produce a key value pair. And what it does is it rolls up all the results of that for each item into a new hash table. If I'm remembering this correctly. Yeah. So what I'm going to do is values, and then the values are the key and the pair. So it can do, this is another function from the TX-EXPR package. C ref. We know there's always going to be a ref attribute in there, so I can just grab that value and then get elements. Now I have a hash table. So this first part is done. Now we want to descend into our doc, our elements, and replace all of these markers with the actual citation. And this is where you get into another handy function called decode. You're going to use decode if you do anything interesting with Pollen. And I believe that is that's in this, let me just scoot up to the top here. If you've done the tutorials, you've seen decode. I don't know why eyeballs aren't finding it here. Is decode in this package or is it somewhere else? Pollen decode. Oh, did I not know that? So really I'm going to have to go up here and require it. That's right. So decode actually will descend all the way down into all these nested elements in the tree and do whatever you want with specific types of things that it finds there. You can have it modify or detect or do stuff with strings or inline tagged X expressions, block tagged X expressions. That has to do with the distinction similar in HTML. You have block level elements and inline elements. Block level element would be like your span, your paragraph, your paragraph, a figure, a div, main, section. Those are block level. In other words, they define blocks of content, and then inline ones are within lines of content. This citations that we're looking for here, these cite tags, they're not necessarily block or inline, but they're just tagged X expressions. So what we do is you call this decode function, you give it your giant tagged X expression, and you tell it, I want you to run this function on each tagged X expression. You don't need to use all these arguments. You probably will only use one or two at a time, but you can use that to have it replace tags, replace elements, replace attributes. And I believe the behavior is that it will replace so it'll replace, I'll show you what I mean. So now we're going to replace all the citations. Define new elements. Decode. I'm going to use a form of this called decode elements. So I can pass it a list of elements and not a temporary X expression like I did up here. I believe there's nothing special about that. Decode elements. This is just takes elements as an input rather than the whole tagged X expression. So I can just give it my elements. And actually I've decided that when I split those definitions off here, I do want to keep, I actually do want to keep the other one. I'll call those boiled ones because I've boiled off the site definitions at this point. So boiled elements, so then I actually will want to use the decode function straight. And that those actually aren't going to be elements, that's going to be the tagged X expression. So boiled tagged TX. So we're going to decode the boiled TX. And we need to give it a helper function, and this helper function is going to be what replaces replace sites TX. We know that what we're getting is a tagged X expression at this point, because the decode function will ensure that this function is not called on anything but a tagged X expression. So I don't have to test for that here. But I will say we're going to replace, and this is where we bring back our old output, which was here. And I have a problem with this that I'll come back to later on. I'm just going to copy this. Apply tooltip. So what we're actually doing here, got to replace it so that it makes sense in the current context. We still have, if I recall, our tooltip function down here, which we can use in here. So we're actually going to, we know that this, okay, let me back up a second here. We're going to, we're in the middle of defining this replace sites function, but we're going to pass the name of that function to this decode here. And what we're actually going to do, we want to make sure that it only gets applied to tagged X expressions. So this, I'm looking at the corner of my eye at the racket documentation for it up here. Proc replace sites. So this function is now going to get called on every single tagged X expression in here. Some of those will be site tags, and some of them will be other tags. I only want to operate on the site tags. So start a conditional here. So when that tag is a site tag, then we are going to apply this tooltip function. We're going to look up in our table that we built here the key, but we don't know what that key is yet. We need to reference that key out of the attributes. tx key. And if it's not there, we want this list. Okay, let's see where my parentheses ended up here. Okay, so my indentation is a little off here for the moment, but if it's not one of those site tags, then we say else, just pass it on through, unchanged. Now I can update my indentation. Okay. That is our little helper function, replace sites. And now we've got a new, actually it's not elements, it's this whole tag dex expression. And I hope you understand what I mean when I differentiate between elements and a whole tag dex expression. The elements of this site def, for example, is this string. It's the list of things that occurs at the tail end here after any attributes. The tagged x expression is the elements plus any attributes plus the tag itself. So I find it helpful to name things in a way that reflects what they actually are. So tx is a good shorthand for a tagged x expression. So I'm defining this new tagged expression to be the result of this decode. And what I can do now, because that is ultimately coming from up here with this TMP tag, I don't have to, I could just actually make that a div. And in fact, when that's done, I'm going to get a div that has everything exactly the way I want it. So I don't even know that I need to save the results of that in the variable, and I don't need to do anything other than use the result of decode as the result of my entire root function. So let's do this. Define. Okay. That should be it. Now, it's telling me at the bottom I have an unbound identifier in key. Really, I see there's no variable here. I really need to replace this with this. It's a duplication. I could use a let form to there's other ways to handle that, but the simplest way is I'm just going to do this for now. You get this rightward drift, kind of common in Lispy languages, but and I'm just going to do it the dumb way for now, also known as the easy to understand way. Now, what happens when we run this now? What should happen is that root function will descend through here, look for anything that looks like a site definition and store it in a hash table and yank it out of the tree. Then it's going to use the decode function and replace everything that is a citation with the markup for a citation, the span and the on-click and all that sort of thing. Of course, I have a contract violation. I gave it the wrong thing. There is no key. You'll recall we're using the ref, not the key, the symbol ref. So that was my mistake. Oh, everything you see here is my mistake. I'm the only one at the wheel. Okay. Try again. Looks to me like we got something going on here. That is correct. So notice, because our boiled tagged X expression was the result of a splitf with this div tagged X expression, that actually gets carried all the way down to here. And instead of having root, we now start with a div. And our citation has been properly replaced with the markup the way we had it before. So the only thing that really remains is to re-implement this insert bibliography, which we also need to do within our root function. So I'm going to create a second helper function here. You know, I could do this with a second call to decode, but you can actually you can chain together a bunch of functions. So in fact, I could do it all in this function. Might be the simplest way. If I add another condition up here, I could put it in there and look for the bibliography ones as well. Let me close this one for now. How did I used to do this? See, why don't I keep this exactly the way I had it? No, because I don't want it to call that. Well, I'll just change the name of it. I'm actually going to move this out of here and back into here. I'm just going to pop it up here for now. No, because I have a name. I already have that function down here. I was going to call it bibliography. No, I see, and I can't put it there. You see me puzzling through these organizational issues in real time. Actually, so I don't have the way we're doing this, I don't have a citations hash table until I'm midway through my root function. So I could call this make bibliography and just pass it that C table. And then I'm making all sorts of atrocious aesthetic decisions here just because I'm hashing through this, but so now we're passing it a hash table and just letting it use that hash table to do the same thing it was doing before. These keys are going to be strings now, so because you'll recall I'm forcibly converting them all into strings within my tag functions. So let's keep it that way. I'm missing a bracket somewhere, of course. So here, if the tag is equal to a bibliography, we will return with the results of make bibliography cite table. No more errors. So I hope you understand what's happening there. I had originally written this function just to replace the cites tags that are left over in the tree, but now I'm using it to do a little bit more. If it finds this bib tag, it's going to replace it with the results of this function, and it's going to pass that function the table that we built it earlier. Let's see if it works. Save all files. Not that it matters. That looks good. You'll notice the way we've coded it, it tends to, it's actually inserting into the bibliography things that I didn't actually cite in the text, but that's expected based on how we coded it. I'm going to start that. It's not going to get it yet because my server's not started, because my computer is being slow. I'm now rendering that page. I didn't get my second one in there for some reason. I'm not sure why. Probably because I didn't save this yet. There we go. So that was a little bit overkill. And we ended up with the exact same functionality as before, except in this case, it will never collide, it will never clash with other pages, because everything is contained in the document and it all kind of gets rolled up into that root tag, and then the root function is called and then it reprocesses everything. This is a useful strategy to have in your tool belt for when you want things to happen not necessarily in a defined order. If you want to not have to think about where you put your tags. For example, on another project I have, the localyarn.com/code, you can preview this project. I've been tinkering with it for years now, and I have yet to release it. But here's the design of it. And in this project, I define all my links reference style. So let me find a page with some links on it. I can click here on this project to view the source code. And let me widen this up a little bit. So you'll notice here's a link tag that I have, and it's saying, okay, link number 1, go to the New York Times piece. That link, I have it at the bottom here, so it actually doesn't get defined until the very end of the document. But I'm using that same strategy, I believe I am here, of, yeah, I am actually. You put in these little, if you don't want to depend on the order, then this link tag actually doesn't produce the hyperlink. It produces a little placeholder. And then it goes back afterwards, grabs up all these URL definitions, and then replaces those placeholders with the actual HTML hyperlink. So the root tag is powerful. It gets the last byte at the whole haple, the whole tree, and you can use this splitf txexpr function to grab anything you want out of it, or filter, split things apart. So you have both the filtered X expression and the list of all the matches. And then you can use decode to actually go back in and replace things. Another use of decode that we'll get into next time is just paragraphs. How do you have automatic paragraph breaks? There's some facilities in Pollen for that, and those are in the tutorials as well. So I don't know how you guys are doing. It's 8:30. It's getting kind of late. I didn't get to everything I thought I was going to get to. But I think this is pretty important. The other stuff, I will save the organization stuff for next time, or I might. Those are some pretty light edits that I was going to be making with some page trees and things. But let me know any feedback you have. I think I'm going to wrap it up here. I will update the repo as soon as I can in my spare time. I'll clean this up a little bit. And then also, if you want to go ahead and take a look at this local yarn project. This is my biggest, gnarliest Pollen project yet. I'm using Pollen to create a giant amorphous knowledge basey type garden or maze of writing. And for it, I am including the source code for everything on the site, and also I'm including my own documentation for all the source code of everything I've written. I have some elaborate caching and kind of one-to-many page relationships going on there. And I write all these notes because there's no way I'm going to remember it all. Yeah, the tips I have are same as always. Do the tutorials. Study what an actually valid tagged X expression looks like, and that you can find in the Pollen documents. I believe this 13.1.4, returning an X expression. There's another part. There's a spot in the, maybe it's in the tutorials. That's what it is. 6.3.3, X expressions. I would really read this in detail, because whenever you get these weird contract violation errors in Pollen, while you're decoding your tag functions, or you're debugging your tag functions, that's almost certainly what you're running into. The error message will tell you that there's a problem, but it's because the tagged X expressions can be so big, you end up not being able to see within the error message where exactly the problem is. But if it's something you've been working on recently, go back and look exactly at the X expressions you're generating and make sure they're valid. And finally, study the decode function and the splitf txexpr function. And the documentation for decode is really good. There's a lot of examples, and this is not something that you always get with Racket documentation. When you learn how to read Racket documentation, you learn how to kind of parse these grammars that they put at the top, but there's not always a lot of examples that show how to chain things together to get what you want. But decode, Matthew Butterick is different, and decode he knew this was key, so he took a lot of time to explain it. and the split FTX EXPR function. Anytime you need to find a bunch of something in a tagged X expression and grab it back out again, that's going to save you a lot of trouble recursing through lists and things like that. So there we have it. I hope you all are enjoying the good weather. And hi again to anyone in the future who made it through this thing. I am on Twitter at Joel D. I always try and tweet about these, you know, ahead of time. Then there's also the there's the email, buttondown.email /pollen time. We'll get you a little sign-up form if you want to get an email a week and a half in advance of the next session. And of course, all the code that we write here is at this GitHub repo, cookbook-pollen, under my other Joel moniker. And so great. Thanks for watching. Thanks for sticking with it. The rewards, in my opinion, are worth it. I hope that you find the same. And also, you know, email me or tweet at me with any questions if you're running into anything weird. If your stuff is on GitHub, I'd be happy to take a look at it, kind of help you puzzle through it. And also, don't forget about the Pollen users repo. And we'll see you guys later. Thanks. And I got to figure out how to turn it off.